Zhewei is another new research faculty with us, and he'll tell us about Slang. Thank you.
Thanks for the introduction, Nadi. Nadi mentioned, I'm Zhewei. I'm a new faculty member here who joined this September, and today I'll be talking about my work, more of an overarching vision on how to make NLP systems more robust to language variation, and a lot of the content will focus more specifically on my PhD work on how do we make NLP systems process slang. So let's start by looking at an excerpt of AI-generated language. If you ask a language model to describe its typical tone when talking to a user, you see this not so concise output that really takes a neutral tone. And many of you probably have already noticed at this point when you were shown, say, like a passage like this, you can ask a question and answer it pretty well, like whether this passage is generated by ChatGPT or not. And not surprisingly, humans are very good at differentiate between AI-generated language and human-generated language. And this is precisely because a lot of these AI-generated language tend to take this more neutral tone without much persona. And I've tried the same question on a more recent language model. It seems that it has done slightly better. And the highlight here is that at the beginning of the sentence, it added like a certainly marker, which made it sound more human. But it pretty much gave you the same kind of response, except in a more concise manner. And in order to come up with this kind of language variation, we really need to retrain the model in order for it to actually make a big difference in the kinds of things that it talks about. But for humans, it's not really the case. And also here's some more data that shows you how humans are very good at differentiating between AI-generated language and human-generated language. So if you there's this one study, if you just show human a passage written by AI, over 80% of the time, the human will tell you that it's generated by an AI, not a human. And there are also studies that look at this kind of characteristics that differentiates between human and machine-generated language. And here are just for a few examples where the AI tends to use more structured language compared to humans, and they tend to use fewer discourse markers like bat, but, and more over. And now let's think about how humans generate language. And the way we use language tend to be more subjective, and a lot of times expresses our feelings at a certain point. We also have the flexibility to generate or interpret different kinds of language in different contexts. So just as a simple example, if you're just saying hi to your dad, say at home, it is totally appropriate to say like, oh, hey, what's up, old man? Just be very informal. That's something that you'll never do in office. You'll rather say something like formal, like, yeah, how are you, Miss Pearson? Instead of saying like, what's up, Miss Pearson? The way we use language also reflects our social background. So people from different demographic areas, demographic groups tend to use different language, and the way we use language reflects our identities. And more specifically, sociolinguists have looked at the kinds of ways where language can vary. And so these are like 3 axes from a recently published paper that asks the AI community to build more sociolinguistic features into language models. And so one of the first varieties of language is dialectal variation. Where people from different social background will produce different language that corresponds to their social identities. We also have different so-called registers of language, and what it says is that the context in which the language were produced really defines the kinds of language that we use. And also, the way we use language is a temporal matter. And it really, depending on which time period you're talking about, it really changes the way you use language. And you can view this in both a short-term and long-term perspective. And so, for example, in a more short-term perspective, say if you're replying someone on a chat app, whether the person sent you a message 2 seconds ago versus 2 days ago will probably change how you respond. And over a longer time span, the way we use language change, and there's a lot of literature that looks at how language changes over time. And one important thing to note here is that these axes are not really mutually exclusive. And just as an example, so say for today's topic, slang, it is mostly an informal language which would fall under the informal register. But you can see how the other two variables also tap into this specific type of language, and specifically here, slang is really tied to social background of people, and depending on which group you come, say like which Reddit community you come from, it really depends on, it really affects what kind of word choices you make and what you mean when you say certain words. And also when it comes to slang, it changes very rapidly. So the way you describe cool today is probably very different from what you would use 10 years ago. And actually, a fun fact, 100 years ago, the word cool is considered a slang, which it actually got conventionalized. So now it's no longer considered a slang. And you will use something like Gucci, like sick instead. And what makes like slang a really hard problem is that you really have this temporal axis where you have to figure out like what kinds of slang people will use in the future, and these are not readily available in your training data.
I'm curious, is there, I mean, what's the definition of slang? I'm just asking because I think of cool as slang. So
that's a very, very good question. Actually, linguists have also confused about what really constitutes as slang. So there's no real definition that tells you like
so
what
what's
a slang is.
when you say that cool is not slang anymore, then what do you mean by that?
Yeah, so I mean for cool, it's really determined by a case-by-case basis. For cool specifically, because it's so conventionalized in our everyday language, that you will find like the term cool meaning good in like any standard dictionary. So in that,
Who made that decision?
lexicographers make that decision. Lexicographers?
Some society.
Lexicon.
Yeah, lexicographers, like the people who write the dictionaries.
Okay.
And yeah, so for the
Arbiters of cool.
yeah, so for the purpose of talk, since we mentioned this already, this is a hard problem, differentiating what's considered slang versus what's considered like everyday normal language. So we leave this question to lexicographers. And I think in the interest of time, I don't have that slide in this deck, but there is an authoritative slang dictionary called the Green's Dictionary of Slang. So think of it as like a more authoritative version of Urban Dictionary. And what we consider as slang is whatever we can find in the slang dictionary. So whatever the lexicographer considers this like a slang, we'll take it as a slang for the purpose of like our work. Yes.
What about a threshold of like, what would be considered proper use in an official document or a legal document? I wouldn't imagine a lawyer writing cool, using cool as a substitute for good.
Right. It's because like cool is still considered as a less formal word.
So the dictionary lists it, but does kind of say slang. Right? It says it's informal, which.
Yes, it's like kind of in between.
Skip it.
Yeah. So just to be more specific on that point, if like the way we took something as slang is that you can find it in the slang dictionary, but you cannot find it in the like Oxford English Dictionary. So we make sure like the stuff that we consider as slang are like really slang in this case, if it makes any sense. But anyways, going back to this overarching research goal on making NLP systems more robust to language variation, and let's take a minute and think about why this is important. And the obvious answer is that we want to make conversational agents more natural by giving them the flexibility to employ a wider variety of language, so that we don't have to tell the agent that, oh, you're like acting as a teacher, or you're acting as like a criminal in this case. Like it can figure out how what it's supposed to do and what it's supposed not to do just by the linguistic context. But at the same time, this is also an important question because it makes our AI systems more equitable. And it really comes down to this performance bias towards different varieties of language. Say if your system can really understand like standard American English, but very poorly on African American English, then if you have a conversational agent that say takes a customer service call from African American individual, then you're really providing degraded levels of service. And by addressing these different kinds of varieties of language, we can really make our AI systems more fair towards different kinds of users. And there are two potential approaches that I can think of based on prominent paradigms in the field right now. And the message that I want to drive through today is that we don't have to train on LLMs all day. We can also take knowledge-driven approaches where linguists and cognitive scientists have studied and know and learned a lot about human language, and we can inject such knowledge into our models to build more efficient models. And the alternative, of course, is just to take a fully data-driven approach where we train a model that's as large as possible and do it efficiently so we can train it on as much data as possible. And the hope here is that by having a lot of data to train on, we would capture all the more underrepresented forms of language. And each approach comes with the unique challenges. So in the knowledge-driven approach, we have to ask like what kind of knowledge to actually incorporate and how exactly we would do it, and it's usually not a trivial step. And in the data-driven approach, of course, you will need massive data sets, and you will need to be like a big company to actually train on a lot of these large language models. And so for today's talk, I'll talk about how we can apply both of these approaches to make NLP systems more robust to Slang, which is a highly contextual type of language that NLP systems also often struggle with. And on the knowledge-driven front, I'll show you how basic models, as of today at least, such as BERT and GPT-2, can be augmented with linguistic and cognitive knowledge to process slang. And specifically, I'll tell you how we can build a computational model of slang sense generation and how we can apply it to slang interpretation of novel slang that you have never seen in the data. And we also try a data-driven approach by just taking off-shelf LLMs and or maybe with like a few fine-tuning steps to see like what kind of knowledge of slang it already has and what kind of tasks that we can do with it. And here I'll show you how it performs on things like slang detection. And if we have time in the future, I'll talk briefly about my future research directions. And so just a quick aside. Slang is actually a lot more common than people probably believe. So in a survey done back in 2022, 94% of Americans said they use slang in some form over the past year. But if you look at the number of papers in ACL type conferences, this is still a very understudied topic. And when we think about slang, there are really two types of slang, so we can partition the kind of slang based on how they're created. And when I talk to people about slang, the first thing that people usually comes up in their mind is this notion of coinage, where we actually coin a new word or a new phrase to express a meaning. So for example, we can combine the word mock and cocktail to end up with the word mocktail, which means like a non-alcoholic drink that resembles a cocktail. And similarly, you can also combine two existing words, such as like bird and course, to say, oh, bird course means like a very easy course. So in both of these cases, you are actually creating a new form that has never been seen in an existing dictionary. But on the other side, we also have these cases of reuse, where we can actually recycle an existing word in our lexicon to express a new slang meaning. So for example, here we can use the word blazing, and instead of saying that something is burning brightly, we can use it to describe something excellent. And similarly for the word steam, instead of someone actually being vaporizing, it really means that somebody is like really angry.
So these things are more like metaphors, I think, than slang. Is there a distinction?
So a lot of slang uses metaphorical extension as part of this mechanism. So I would say like slang includes a lot of metaphorical usage, but it's not necessarily a metaphor.
And if I'm one quick question, so are idiomatic expressions also part of slang in your opinion?
Yes.
Okay,
Consider
nice.
them as slang.
Even if there are no idiom. Even if there are no idiom.
Oh, like it really depends on like whether you're creating like a new phrase. So if you have like a new phrase, like bird course, and you can argue whether it's like an idiom versus not, depending on who you ask. Yeah, so it always ends up to the lexicographer's judgment, and they usually provide you like a list of guidelines. So say we have like these 4 different characteristics that we're considering. If it meets like at least 2 of the 4 criterions, we'll consider as a slang. So to give a way to have some consistency in how they judge, but no one really agrees on what's right versus what's wrong.
How do you distinguish a case where, in fact, the person is using the term as it is defined, but it's used in that context, otherwise you wouldn't use the word? Like, that's what gives it a slang meaning. Like, I could say, this man was steamed, and he was like, yes, in some sense he was vaporized, but colloquially this means that he was, someone kind of like lit into it.
Yeah, so like in the example you provided, it's not really used as a slang.
I think some people would say this is a colloquial usage of the term.
Yes, it's a colloquial usage, but it's not, at least not not a slang in this sense. It does not invoke this particular slang meaning of steam being used as being angry.
I see.
So one thing I think of with slang, coming from a linguistics background, is that it has to do with like in-groups and out-groups, and something stops being slang when it starts being used by the out-group. So we can think of like generations maybe. Gen Alpha has like skibbity and all this weird shit now. But like once I start saying that, once ever I figure out what it means, then it probably will stop being slang. But then one thing I'm wondering is that there's like this very sort of informal process, and it's so rapidly changing, but at the same time, if we're relying on like the lexicographers who are probably not hanging out with the cool kids, like I guess I'm wondering about that sort of tension, because it is so rapidly changing by people who are not really in the ivory tower. So like, what does it mean to rely on sort of these kinds of dictionaries?
Yeah, that's a very good question. So just to make a comment on like what you said first, it is indeed the case that once something becomes conventionalized, when it enters the general lexicon, it is no longer considered a slang. And what kind of like how popular it has to get before it is considered as conventionalized is really based on like a case by case basis. And so you can say that okay, if somebody's like if a slang is used by like the cool kids on like by the Gen Z people on the Reddit, then it's like really a slang. But once it's like used by people in like my age, it's not necessarily a slang. But when you take the perspective of someone much older, you're like yeah, it's still like people's in their 30s you're trying to use this slang, so I would still consider that as a slang. And so I think the way we use the dictionaries as a way to decide whether something is considered a slang or not is really a way just for us to have some consistency in how we make the judgment. So we have like a single lexicographer who will judge like all the slang cases or versus the ones who are not. So at least for all these cases that were counted in the dictionary, there are some consistency.
You kind of mentioned that you are defining a slangs by the vocabularies that you can find in the Slang dictionary, but not in the Oxford dictionary,
Yes.
which will not capture the reuse slangs. Is that true?
We actually look at specific senses.
Okay.
So in this case, if say we look at the word steam is in Oxford English dictionary, but the word like being angry, like the sense being angry, will not be part of that sense, like word entry, lexical entry. So like when you think about these like reuse cases, it's really the mapping between the word and the sense that matters. Like you don't necessarily need to express a completely new sense, but the fact that we're attaching a new word to that sense makes it like a novel usage. Any more questions before we move on? Okay. Yeah, so here's just a space of problems that we're interested in for Slang when it comes to NLP, and I have already briefly mentioned a lot of them. And so on the processing side of things, we would really love to be able to detect slang, as someone has mentioned, whether we're saying like, oh, someone is like actually literally being steamed, or someone's just like steaming because he's really angry. We want to differentiate between these cases, and we can make our models make these judgments. And at the same time, we also want to allow our models to figure out all the new slang that say like cool kids are using these days, and by just giving it a meaning that we want to express, and say what kind of words we want to come up with to express that meaning as a slang. So in other words, asking the model, if you were like the cool kid on Reddit today, what kind of word would you use to express this meaning? And we also have the reverse side of interpretation, where if we actually see some slang usages in a text corpus that doesn't make much sense, we want our models to be able to interpret the correct meaning. And as a result of generation and interpretation, we also want to do like slang to slang translation, where not only we want to say translate the word blazing to its literal meaning excellent, we also want to say find a slang in the target language, in this case Chinese, that also expresses a similar meaning. And on the more linguistic side of things, we are also interested in studying the variational aspect, or modeling the variational aspect of something like slang. And here we usually have two types of problems, where first is lexical variation, where given the same meanings, we can have different words that expresses the same meaning in different demographic groups. We also have semantic variation, where it's the opposite, where we have the same words that can be used to express different meanings in different groups. And I'll show you how existing models can be augmented to do generation and interpretation, and how large language models can be used off the shelf to really do detection and to figure out the variational aspect of slang. And so the first question I will talk about is slang generation. So again, we have a speaker who has a meaning that he or she wants to express. And maybe now in this case, instead of saying like angry, we use the word slang word steam instead. And here the research question we want to ask is that why do we actually choose the word steam instead of alternative words such as like ice or cake? Why do we really have to say I got really steamed when my car broke down instead of say I got really iced when my car broke down? And before we jump into how we can do this, let's find some intuitions from previous work where people have injected linguistic structures into modeling creative language use. And so one example is metaphorical generation, where it really relies on this conceptual mapping theory by Lakoff and Johnson, where you have conceptual metaphors where you're tying a source domain to a target domain. And based on that conceptual metaphor, you realize linguistic metaphors such as they fought against the contract instead of they argued against the contract. And by having this consistency in the way domains are mapped, you can generate novel linguistic metaphors, such as they defended the contract instead of saying like they explained the contract. And there's also work on pun generation that looks at incongruities between two different usages. So I'll just give you a minute to read this example, and you can see that there are two different ways you can interpret this word based on the sound. You can have the dye as a pigment, meaning which fits in the global context but makes no sense in the local context, or you can have the die as dead sense that makes a lot of sense in the local context and it does not make a lot of sense in the global context. And this mismatch between the between two different contexts is what makes the pun actually funny, and this is what the incongruity theory says. And you can use this sort of intuition to come up to generate like new puns. And now going back to slang, what kind of linguistic structure that we know that we can latch on will be very important. And we do this by looking at two very simple principles. The first is that there exist non-random relationships between the extended slang sense, for example, good, excellent, to the original conventional sense of a word being reused. And in this case, we argue that there is a non-trivial relationship between the sense being ill and the sense good, excellent. And as a corollary of this, we're basically saying that there is no randomness in how these words are chosen, and they really there are really consistent patterns based on data. And we can take a step further and say like the way these senses are transformed are consistent in many of the tested usages. So in this case, if you have the word sick that has a connotation change from something negative to something positive, and you see another example, say wicked, that also goes from something negative to something positive. Perhaps if you see like something similar in the future, this will likely be the kind of patterns that will be applied. And this is the kind of things that we try to learn from dictionary data. And so to show you how the first principle can be applied, where we argue there's non-random relationship between the two senses, I'll briefly introduce this idea of categorization models, which are generative models from cognitive science that explain human behavior in how people assign different stimuli to pre-established categories in the human mind. And for example, you can have like a category of birds, where we have like eagles on the left and robins on the right. And now we're shown a new picture, and we ask the human like which category it belongs to. And under this modeling framework, we have the exemplar model where we can compare the stimuli to all the examples from each category. And this is by Nosovsky. And we also have the Roche prototype model, where for each of these categories, we pick one example that's the most representative, or we can actually like average these different examples to create like a virtual prototype as well. But in this case, for simplicity, let's just assume like one of the pictures is the most representative, and we simply compare the similarity between the prototype and the stimuli. We can also do one nearest neighbor, which computer scientists really love. Really doesn't really exist in the realm of cognitive science, but that's also something you can try. And not surprisingly, people have sort of reinvented all these modeling strategies in deep learning as well. So, and this has been actually similar ideas have been widely applied in few-shot or like zero-shot learning. And now we just have a different set of terminology. So you have an example that you're trying to classify into two of these classes, and each of these exemplars, now we call them like attributes or support examples, and yeah, we just figure out how close this one example that we were trying to classify against like each of these support examples. And this has been applied very successfully to modeling word sense extension in learning how word acquire different senses when it changes over time. And so just as an example here, now instead of having categories of birds, we take each word as a category instead, and each of its dictionary senses as an attribute or exemplar. And now given a sense that we are trying to generate a new word choice, so in this case being angry, we compare it with, sorry, I think I skipped a slide. Yeah, so we compare it with like each of the conventional senses of a word candidate that we're trying to put onto this sense to express this sense on. So the appropriateness of using the word steam to express being angry can be broken down into looking at how similar the sense being angry is to each of these pre-existing senses of the word steam. And we can try like exemplar model. In this case, we can also do prototype modeling, which happens to work really well in this case. And now if we actually do a quick evaluation by just trying that, just applying that on data, we find that it already performs much better than prior models. So here on the x-axis, it shows you like the number of retrievals a model is allowed to make, so as a percentage of the size of the entire lexicon. And the y-axis tells you how likely it is actually for the model to retrieve the correct word out of, say, like 1,600 words. And this is really an area under curve evaluation. And the $1 million question here is, sorry.
Quick clarification question. So if the number of retrievals is 1,000, you mean like you do pairwise?
So like for each example, like
Yeah.
for each test example, I'll make like 1,000 retrievals.
Uh-huh.
And so like it will give me like the top 1,000 answers, and I will try to see if the correct word choice is within those 1,000 answers.
So it's recall then, not precision.
It's like area under curve.
It says precision on the y-axis here.
Maybe so. What's the test here? You're given the slang word. You're given
So I'm given the meaning that I'm
the
trying
meaning
to
that you're trying. You're trying to come up with words.
Yeah, I'm trying to come up
And
with
you're
a word
saying
choice.
that if you come up with 1,000 and there's a ground truth word
Yes.
that you don't know,
Mhm.
you're saying that if you generate 1,000 words, then with 60% of the time, one of those 1,000 words would be the right one.
Yes.
So it's not exactly precision.
Yeah, it's not okay.
Okay, so now the $1 million question is how do we actually represent these senses when we do the comparisons? We can do like baseline methods, such as just taking the average word embedding of the content words within a definition sentence, or do something more involved, such as taking a sentence word embedding of the entire definition sentence. And the limitation with these more baseline methods is that they compare two senses at their face value. So for example, if you have a metaphoric extension that goes from like vapor to being angry, these models will not really consider these things as similar because you have like this wild non-literal extension. But we know that some of these more non-literal extensions are consistently being applied in our data. So for example, here we have like this flip of the connotation, and we want to be able to capture regularities in these sense extensions so that when we are given a new word such as bogus, which means fake, because of how the words sick and wicked has been has been extended in the past, we can make an educated guess that say, oh, here a bogus probably means something good or something genuine, just because we have these like past examples. And in order to capture these regularities in the sense encoding, we apply contrastive learning that tries to bring together pairs of corresponding slang senses and their conventional senses in the dictionary. So here for the word steam, we take the slang sense being angry and pair it with the conventional sense vapor, and we use max margin triplet loss to bring together these representations in the underlying space. And for a sense that is really not related with a particular word, we try to make it as far apart as possible. And by doing this, we're really capturing the kinds of semantic extension patterns that are in the data. And we see that our models are able to perform much better in terms of retrieving the right words. And when we actually look at these semantic proximity scores from different models, we see that not only do the distances between corresponding words shrink in the training set, but there is also a significant reduction in the test set, which tells us that these patterns can indeed be generalized. And what linguists proposed about these like consistent patterns are in linguistic sense extensions are indeed true for slang as well. And our model is able to capture these extension patterns. And here are just a few examples. Yeah, sorry.
Really quick question. So since you're averaging the embeddings, how would what is the role of things like negation? Like, does that matter for in this case? Like, because if I said I'm not feeling very good, it has the lexical items very good, but it also has not in it. Does that matter for this setting? Because in some examples you're contrasting evil with good, and you're using the same word, so it might not matter. But what intuitions? I was wondering what intuitions you had.
Yes, that's why we have like different kinds of encoding strategies. So something as you said, like in this fast text strategy, it wouldn't just be like thrown out.
Right.
And that's arguably why it's not doing as well. Like just if you just compare it with like the version.
I see. Oh, I guess it will also depend if those things were present in your data set, right?
Yes.
Right. Okay.
Yeah, and also like in the fast text version, if you actually just don't like filter for stop words at all, it performs much worse because it's got like all these different noise. Like it tends to average out all the representation. Yeah, but if you just do the like a sentence word encoding, it won't have that problem.
So you define like how slang is, like you define slang and how you define like the context to be retrieved, like because it's saying it's a long sentence and then you need to like contrast with like different contexts to fill in a slang, and how you define to extract it from a sentence, or?
So I think we were talking about two different things. So first we have the linguistic context, which is a sentence that contains the slang word usage. And so that's from like the dictionary. And so for the word itself, we also have definition sentences of how this word is being used. And that's the thing that we're contrasting.
Yeah, but like you do like during the retrieval you have like maybe 1,000 different things that you can retrieve. Where are those?
Oh, these are just different like words in our existing lexicon. So say if our lexicon contains like 1,600 words,
Oh, it's like
then we're picking like from these 1,600 words. Yeah, so let's just look at some of the examples that our models have generated. And it really, this is really a hard question to evaluate because humans also tend to have very different opinions on what kinds of slangs are good versus not. My favorite is this red example where we're trying to ask a model to pick a word to express like a communist or socialist person. But instead of coming up with the correct color red, it comes up with things like orange, bluey, which means the model has some sense of this relationship between like ideology and color. But without like grounding it to like world knowledge, it has no idea that red is really the color that's supposed to be used here.
So in what sense is that? I'm a bit confused. So what is this trained on? I mean, it obviously is grounded to some word knowledge. So I'm a bit confused as to what this is actually trained on.
Oh,
why
yes.
does it not include the fact that the red this does this word?
Yeah, so we train it on say like a couple thousand of slang extension examples, where each example contains like say what the sense was and what the sense.
But you also use the word embedding trained on something.
Yes, we use a word embedding.
Wasn't that trained on text that includes this meaning of red?
Yes, it is, but I guess it's just because these embedding models aren't like that strong to begin with, it did not really encapsulate encapsulate the word knowledge.
So what we're basically is it correct to say what we're seeing here is that the word embedding is just not. It's just a failure of the word embedding that it gets kind of like in the right area but doesn't get the actual term.
Yeah, I think that's a good way to put it. So in this case, like say if our word embedding really tells us like a communist is like should be really close to the word embedding of red, then we will have something like that.
I guess my issue is it seems to me like it's just finding out what is the real meaning of the word as opposed to coming up with a new meaning. I'm not seeing this distinction because this is a real meaning of the word red that should be in the word embedding space. And so should I interpret this as it's coming up from different terms, different new generations, or it's not about generation, it's just failing at finding the word that already exists.
Right, so it's the assumption here is that in our word embedding models we don't have like the knowledge of these.
Why is that assumption reasonable?
Because like if we apply these word embedding models directly on cases like this, it will fail pretty badly.
Let's go on. I'm a bit confused.
What is the input and what is the output? The input the word or the meaning?
The input is a meaning, and we're trying to predict this word red in this case.
So you're saying that word embeddings fail in defining words? I mean, good word embeddings don't fail. So you're saying that
it fails on slang words.
So, what word embedding do you use here again?
Fast text.
So how does that handle polysemy in general?
So the way it handles polysemy for individual words is by looking at like the subword units and by invoking the context.
So okay, so if our bank is like the Bank of the River versus the Bank of America, then we'll just use that context.
Mm-hmm. So like when you talk about context, it's really the context within this definition sentence, but not so much to this like how this.
So if I say the red robin versus the red scare, it should embed the word red to different embeddings, but you're saying it doesn't.
Like we're not actually embedding the word red specific in this case. We're embedding the definition sentence of red,
which includes that.
Which includes, I guess what I'm confused goes back to the definition of slang, because red is probably in the OED as meaning communist.
Sure.
And so I'm a bit confused here is what are we doing here is defining words or generating? I mean.
So like in the case of red, if it's marked as an informal sensing OED, we basically take it out. So we're trying to see if the words, if the formal words in the conventional dictionary, such as OED, can be used to extend to more creative informal senses that we see in the Slang dictionary.
Do you think these questions are still difficult for current state-of-the-art language models?
It is less so, but it is. I'll show you some examples later.
So you're basically trying to see if the model generates the same slang that humans have already heard.
Yes.
Okay.
Yes. But the models have no idea that this extension it exists. So to the model, this is like a zero-shot generation. So with this like generative model, we can actually apply it to the reverse problem of slang interpretation. We're given a sentence with the slang usage, and we can ask the model to actually tell us what the correct meaning is. And the model needs to differentiate between the correct meaning being angry versus other potential meanings that we can consider. And previously, we have approaches that focus on the context. And so this is a simple encoder-decoder architecture proposed by Santa Barbara Group, where you essentially encode the context sentence, you do a character embedding on the word itself, and then you try to ask the model to do a free-form generation to come up with a definition sentence. And we can also do something simpler using one of Mina's models. So for example, we have like a GPT-2 model, which is an autoregressive model, and we can turn it into fill in the blank technique and ask the model to fill in the blank given the context sentence. So in this case, we will blank out the word slang word steamed and ask the model to make predictions on what kind of words that fits well within the context. But the thing about these like more contextual approaches is that the context can be under constraint. As you can see here, you can say like the word drunk fits pretty well in the sentence, but then with respect to the word steam, maybe not so much. And so we leverage these generative models of slang sense extension to come up with a re-ranking strategy that asks. So say if I want to interpret this word steam as angry, I want to re-rank the appropriateness of this interpretation candidate by asking the question. So if I were to generate this new sense, what kind of word choices will I make? Will the right word steam be an appropriate choice here? And we can use the same type of modeling strategies as before, and we can apply it to each of these interpretation candidates that we have. And now, since we see that it is very likely to use the word steam to denote something like angry, then we should really give more higher score to the word angry. And the advantage of this model is that because it's a re-ranking strategy, we can apply it to all sorts of different kinds of generative models that gives us a list of interpretation candidates. And we applied it to different models on different data sets. So we do like a GPT-2 based language model and the dual encoder architecture proposed by the Santa Barbara group, which is actually in this case trained on like about 400,000 examples from Urban Dictionary. And we find in each of these cases we can predict these new words with higher accuracy. And now let's turn the page and talk more about the kinds of knowledge that we have in large language models about slang. So in this case, we're not really injecting specific knowledge into these models. We're just hopeful that by training on enough data, these models, the knowledge about these like specific varieties of language would emerge from this training process. And the kinds of questions we want to ask here is that can these knowledge be automatically learned? And if so, how much knowledge these large language models actually contain, and where do these knowledge possibly come from? And to do this, we evaluate the large language models using two simple probing tasks. The first one being slang detection, where the model needs to tell you whether a slang exists in a sentence, and we can do this at both the sentence level, where the model will just need to say yes or no, or at the word level, where the model actually has to tell you where exactly the slang term is. We also do this source identification task, where given a sentence containing a slang usage, we want the model to infer the demographic information of this usage. And we also look at a few intrinsic tasks, and what I'll show today is we will be comparing language model probabilities of, say, slang versus literal term. So for example, what's the kind of probability scores that are assigned to, say, like blazing versus excellent in this case. And to do this, we actually come up with a new benchmark and with a bunch of desirable features that allow us to do these type of probing tasks. And we release this new data set, and it's based on open subtitles. And now let's take a look at some of the results. So we compared against a group of earlier models such as BERT and Roberta to a couple of more recent GPT models. And most of these GPT models are off the shelf, with GPT 3.5 being fine-tuned on the same data as the earlier models. So like all these earlier models, they do require like fine-tuning to work. And what we find is that these zero-shot models, they're really good in the sense that you can achieve like a good performance without actually fine-tuning these models. So which tells us that these models are indeed having some knowledge about slang without even having to do the specific training that we have to do for the earlier models. However, these models are actually very competitive once you actually put in a couple hundred or a couple thousand examples. So I think in this case it's like less than 1,000 examples of fine-tuning. And in the case of GPT 3.5, once it's fine-tuned, it can actually achieve significantly better performance in some cases, which tells us that although these language models, they do have pretty good knowledge about what it constitutes for some, whether something is slang, it can benefit a lot from further fine-tuning by providing it task-specific data. And another interesting thing that we find here is that the detection performance seems to really differ based on where the slang comes from, whether it's a US-based slang or a UK-based slang. And in this case, we find that it's more likely for many of these models to detect a UK-based slang from a US-based slang. And we will see why this is the case with like a few intuitions later. And we also ask the model to identify the source of a slang usage. And so here we have 3 different conditions. The first one where we just feed in the original sentence to the model and ask the model whether, say, this slang usage in the sentence comes from the US or the UK. And we have 2 other control conditions where we mask out one of the content words, and in the second condition, it's always the slang word, and in the third condition, it's always a content word that's not a slang word. So if the model is really using this like slang word as a feature to infer the demographics of the usage, we should see like a significant drop in the second condition, but not so much in the third condition. We indeed observe this kind of behavior in many of the models that we have tried. So in this case, say in the case of BERT, we see like a big decrease in performance when we mask out the slang, but not so much when we mask out the content word. And what's really interesting here is that for GPT-4, this is not so much of the case. And we postulate that this is because with the RLHF training, it becomes more sensitive when it comes to these more demographics-related questions that we ask. Yeah, so in the end, we also compare the kind of language model probabilities the models assign to the different tokens in the sentence. And so in the interest of time, the punchline here is that, perhaps not surprisingly, that GPT-3 actually assigns higher scores to slang versus the literal counterparts. But more interesting here is that it seems to be much more confident when it comes to US-based slang versus UK-based slang. And this is one of the possible reasons why the models are so confident when it comes to picking out the UK slang in the detection task. Because for a lot of the US slang, the model sees enough of these usages to think that they're no longer part of, like, say, the slang group. So the model will consider these language to be more conventional as opposed to on the UK side. So I hope that I can drive home a few key takeaways today, that the knowledge about slang can indeed be learned by training LLMs on lots of data. But if you want to achieve good performance, we still need to fine-tune the models with high-quality data. And smaller models are still very competitive if efficiency is something that you want to consider. And for a lot of the low-resource languages that we have in the world today, we still have to inject structural knowledge about language variation, which can be very effective in cases where we don't have like a large corpus to train on. And just a few things to say about future directions. So my goal is to make NLP systems more robust to language variation, and here are the 2 things that I'm really interested in looking at. right now. So first, to examine how individual demographics affect dialectal variations and how large language models will react to such variations. And also, I'm trying to inject temporal structures into large language models to build real-time agents that can better understand the context of time. So if these are the kind of questions that you're interested in, please come and talk to me. And yeah, here's my contact information and a quick shout out to all my wonderful collaborators. My work won't be here without their support. And yeah, I'd be happy to take any questions. Thank you.
Questions?
So one aspect of this of slang, which I think you haven't talked about, is that it seems like some words are much more likely to be the target of slang than others. Like there's a lot of slang for emotions and maybe some relationships, not so much for household objects or some other things. Is that something which you have thought about, linguists have thought about, or
Yes,
the models?
Actually, I looked at in the very beginning of my PhD. So what I did was actually to come up with a topic model to see what kinds of topics are more likely in slang versus not. And this is certainly something that linguists have also looked at. And it ends up being that a lot of these slang terms are used to talk about things such as like drug or sex, which are the kind of examples that I can show, but these are very prominent in this like data set.
That's a subcultural kind of aspect, I think. But there's also like all those examples you presented. Most of them were about emotion or emotion-laden judgments, quality or something like that. So is that something that?
So this is actually changing over time as well. So in the past, say like from before 1960s or 50s or 60s, it is more likely to be the case that you use slang to describe like subcultural things or things that you're trying to like evade authority. But then until more recently, I think it's been like an increasing trajectory. But very recently, like in the 2000s, when you have like all these online communities and social media, the way people create slang is really changing as well. But so like for our studies, we did like historical analysis from like 1950 all the way to 2000s, and we find that like through time. So if we do like all these generative predictions over time, so say we train on all the entries up to like 1980, can we predict the kind of word choices that are made in the next 10 years, and we see the models provide give like very similar performance as if we just like say treat everything like that on top.
Questions? Maybe there's a question.
Hey, thanks for the talk. So when you talk about your future directions at the end, part of it is studying like probably like the most modern LLM systems. And so like you alluded to, a lot of the time the version is publicly available is like fine-tuned after the initial training. And so I would like, so there's some RLHF layer that like constrains the behavior of the original model. And I was wondering, for your research, do you think about like these two stages of training, being able to have access to one model versus the other as being important, or it's really the final system that you think is most important?
Like both systems will be important, like if I have access to both versions, because RLHF really changes the behavior of the model, especially when it comes to these like subcultural things or the kind of things that the model would rather not discuss. And I think like as a glimpse to this, we see that like for GPT-4, the kinds of predictions that it makes is really like the behavior it shows is really different compared to the other to the GPT-3 type of models, and but not surprisingly, like the actual raw performance is actually higher when you ask the model to actually do this prediction. But then when you try to make like more fine-tuned, when you actually try to look into drill into the models to see what it's doing, it's actually doing something very different. And yeah, so to answer your question, I think like both types of models are very interesting to look at. And I think like nowadays, because people are doing so much like inference time compute on these like different models, we can like actually just treat them as like two different types of models.
Thank you.